Hello, my name is Yimin Chen, and along with my colleague Chris Brogly, I'll be speaking about a project that we've been working on at the Language and Information Technology Research Lab at the University of Western Ontario with Dr. Rubin, Sarah, and Tolu, some of the other presenters who you've already heard from in this panel. And this is our clickbait detector as an example of more transparent systems design in natural language processing. So as you've heard from our previous speakers, one of the biggest issues with AI is that users and often even the programmers themselves aren't completely sure how it all works. You've got a bit of a black box problem. Where you feed in the data and then magically computer science happens. And then you get some kind of output. And this output is, of course, often useful on some level. Otherwise we wouldn't do it. But without having at least a decent grasp of how we get from point A to point B, we can't be fully confident in the results. After all, how can we trust a decision if we don't understand how it was made? And so one of the ways in which we can increase the explainability of systems is, for the user anyway, is through transparency. And this goes beyond simply telling people what the inputs are. They also need to know essentially how the process works as well. So they need the answers to questions like, what is the system doing? What parts of the input data is it paying attention to? And of course, what are the conclusions based on? So essentially, what we should try to do is to open up that black box as much as possible and sort of allow people to have a peek inside. And of course, also some user-friendly visualizations of the results doesn't hurt either. So this is a screenshot. The example we have today is our clickbait detector, which is part of the literal news verification suite. So this system was designed to take in headline text from news websites to then determine the level of so-called clickbaitiness that is present. So clickbait is defined as, quote, content whose main purpose is to attract attention and encourage visitors to click on a link to a particular web page. And generally, this type of content is seen as low quality, exploitative, and quite often a contributor to the spread of misinformation. My colleague Chris will be giving a demonstration of the clickbait detector in just a moment, but this screenshot shows some of our efforts, at the very least, in creating an understandable color-coded interface. So as you can see here, green is good and not very clickbaity, whereas red is heavily clickbaity and therefore, kind of bad. So like I said, it's important that the processes are transparent and understandable. And for our part, this has meant publishing the details of our work in a number of publications over the last couple of years, as well as releasing the source code of our systems on GitHub. And of course, while the sort of finer points of the system may not be entirely understandable to users without a computer science background, what I have here on this slide is a list of the top 20 out of 38 textual features that our clickbait detector looks at in order to make its decision. So here we have things like the number of pronouns, number 1 there, for example, or the presence of profanity or vulgarity, which isn't on this page, it ranks a bit lower at number 28. As well, adverbial phrases, number 6 there, are a common example of hyperbolic exaggerations and has proven to be fairly predictive. And several of these features were informed by earlier work that we've done at the Literal Lab, part of which involved asking human news readers about how they identify and perceive clickbait articles. So in essence, the purpose of this is to, show our work, if you will, to present the reasoning that our system uses in making its decisions transparently. And so that user can then understand what's going on and thereby have some basis to judge whether or not they should trust the output that they receive from this system. And so without further ado, I'm going to be turning it over to my colleague, Chris Brogly, who will be doing the demonstration part of this segment.